plus 1. So number 11, you got y squared equals x plus 1, y squared equals 3 minus x. And you can do this in terms of x, but the problem is the way it's set up, right now you can't do it in terms of x because y is not solved for. Does everybody see that? Like, what would you have to do to be able to do this in terms of x? You'd have to solve for y. Like, this equation is not even solved for y. What would you have to do to solve for y on this one? Square root of x plus 1. But the problem is it's actually plus or minus the square root of x plus 1. So which part do you want? And then over here, what is it? Plus or minus the square root of 3 minus x. So that makes it a little more complicated. So what the directions said to do is they said don't do it in terms of x, do it in terms of y. So what you do here is you actually take the equations and you solve for x. I'll go back and show you what it looks like in terms of y. So it would be x equals, that one would be x equals y squared minus 1. This one over here would be x equals what? 3 minus y squared. Now let me explain how you graph in terms of y. When your graphs are in terms of y, make sure your cell phone's put away. Here's what it's going to look like. Okay, we're going to go in terms of y. All right, the first one, y squared minus 1. What does that look like? It's a parabola, but it's not like you think. All right, here's how you do it. Just do it completely backwards. Usually we would say it's opening up and go down 1. But we don't deal with up and down when we go along the y. We deal with left and right. So we're going to go left 1, opening to the right.
This one that you did right towards the end of the morning.
So that's what that looks like. And then we're going to go this one, we're going to do what? Usually we'd go up 3, but what are we going to do? Right 3, and then we're going to open to the left. So what you're going to have is this area. Now let me tell you the benefit to doing this along the y-axis. Because here's the area you've got. You got all this. And I want to go from here to here, which happens to be -1 to 3. Is that correct? Is that right? Did I do that right? Yes. Yes, no?
Yes.
Okay, that's right. Now, here's the deal, though. They told you in the directions to do this along the integrate with respect to y. So we're going to integrate with respect to y. Watch. We're going to do the definite integral. And area between two curves is usually top minus bottom. But when you do along the y, you don't go top minus bottom. What do? We go right minus left. All right, so what's the one to the right going to be? Which one is it?
3 minus y.
The 3 minus y squared will be the one to the right. So you're going to have 3 minus y squared. Guys, quiet. This is the 3 minus y squared one. No, sorry, that's not right. This one is the 3 minus y squared one. And this is the y squared plus minus 1. So we're going to take the function that's to the right, and we're going to subtract the function that's to the left, minus the function that's to the left, which is y squared minus 1. And we're going to have a dy. Now here's the deal. Usually these limits of integration are in terms of x, so you would be wrong if you put -1 to 3. Because we're going in terms of y. Everything's in terms of y, so we've got to go, we need to figure out what this is to here. You do. And this one works out really nice because it's not a calculator. So this one, you just set them equal to each other. So I'm going to take 3 minus y squared, and I'm going to set it equal to y squared minus 1. Now watch what happens here. This works out really nice. You're going to get 4. If I add the 1 over, I'll get 4 on that side. Add the y squared over here, I'll get 2y squared. Agreed? Yep. Divide by 2, we're going to get 2 is equal to y squared. What does y equal? Plus or minus root 2. Well, we obviously need both of them because this one's obviously the negative root 2 and this one's the positive root 2. So we're going to have to go from negative root 2 to root 2. And then you definitely would do what before you integrate? What would you do before we integrate? You would simplify. So we're going to have, that's going to be minus 2y squared. Agreed? So that's good. And then you're going to have a plus 1, so you're going to have a plus 4 dy. And then you just integrate this, so this is going to be y to the 1. Third, divided by 3 plus 4y, FTC it from negative root 2 to root 2. Let's go ahead and finish it. So then your FTC part 2 would be negative 2/3 times root 2 to the third plus 4 times root 2. There's your f of b minus your f of a. So we have negative 2/3 times negative root 2 to the third plus 4 times negative root 2. Right? This right here, what's root 2 cubed?
2 root 2.
2 root 2, thank you. What's 2 root 2 times a negative 2? What is it? Negative 4 root 2. So negative, I'll tell you why this way is actually better than doing it along the x here in a second, because some of you are probably like, I wouldn't want to do it along the y. It's better than the x, I promise you. 3 plus 4 root 2. Here we distribute, this would be negative 2 root 2, right? Would that be negative 2 root 2?
It'll end up being positive.
So it'd be positive, but then there's a minus sign there, so it's going to be positive 4 root 2 over 3. That'll be a minus of 4 root 2. Now I distribute the what? Negative. So we're going to get negative 8 root 2 over 3 plus what? 8 root 2. Now some people are like, how do you know this is positive? I'm pretty confident it's positive. If you find a common denominator, that'll be 24 root 2 over 3 minus 8 root 2 over 3. That'll be 16 root 2 over 3 for the final answer. But you could certainly leave it like this. Okay? That is your answer. Now let me explain something to you. That was doing it along the y. Do you know how much harder it'd be to do along the x? Why would it be harder to do along the x? So you'd have to split it up. That's why they had you do it along the y. If you did this along the x, you'd go from negative 1 to 3, but here's the problem. What changes is what's on top. And what changes is what's on bottom. You would have to split this up how many times?
Or can you explain why root 2 cubed equals
Root 2 cubed is 2 times 2 times 2. 2 root 2. Does that make sense? Yeah? No?
When you're doing the root of something, you find pairs that multiply with it.
Okay, 8. 2 cubed is 8, right? So then it's 4 times 2. The square root of 4 is what? 2. That might be a better way to look at it. All right, now, when you do this, so from here to here, if you do it on the x, you got from negative 1 to whatever this point is. This is the top function, and this is the bottom function, right? But then here, all of a sudden, this one's the top one, and this one's the bottom one. And then here, this is the top one, and it switches back to this is the bottom one. How many integrals would you have to do? 3 different integrals to do it along the x.
Why would they intersect at the same?
Well, maybe my graph's just drawn stupid.
Because
Those points should be at x equals 0.
Should they be right underneath each other?
yeah.
Then it'd be 2 integrals. But still, 2 integrals. I don't want to do 2 integrals because then I got to do 2 FTCs. Doing it along the y, sorry, I didn't draw my graph well. If it was like that, then it would be what I had. But along the y, how many integrals do you have to do? Just 1. Along the x, how many integrals do you have to do? 2. So you got to do FTC twice. That's twice as long. And then the other thing about doing it along the x, some of you got to figure out what you have to realize here is which parts you're using. Here, you're using the positive square root of this one and then the negative square root of this one. Here you're using the positive square root of this one and then the negative square root of this one. And so that gets to be a little messy because it's piecewise. So do you see why there's a benefit to doing it along the y now? Okay? So sorry I said there was 3. There's only 2. My graph's just bad. It's just a bad graph.